The kakapo is a bird the size of a house cat that cannot fly, cannot run from anything that hunts it, and smells so strongly of honey and flowers that predators can track it by scent alone. Scientists found 12 of them left on Earth, and then, using a method no one had ever tried on any animal in history, they brought it back. What you are about to hear is not a conservation success story. It is something stranger than that. It is the story of how a team of 16 people overrode 4 million years of evolution, rewired the mating system of an entire species, and made the impossible arithmetic of 12 surviving individuals work in a way that every population biologist said was not possible. The number today is not 12, and the journey from that notebook entry in 1995 to where this species stands right now will change the way you understand what the word extinct actually means. But before we get into the story, please subscribe to our channel so you don't miss future uploads. There are birds alive today that should not exist. That sentence is not metaphor. It is the clinical conclusion of the genomic analysis published by the Kakapo Recovery Program after the 2019 breeding season, when scientists sequenced the full genome of every living individual and compared the results to what the models predicted should have happened to a population that passed through a bottleneck as severe as 12. The models predicted collapse, lethal allele expression, developmental failure cascading across generations until the line simply stopped producing viable offspring. The models were wrong. The birds kept hatching. The question of why they kept hatching and what the people watching the nest cameras did to make sure they did is the real story. And it starts not in a laboratory and not in a government office, but on a remote island in the southern Pacific, where a ranger walked a trail he had walked 100 times and came back to a field station and wrote a number in a notebook that ended the world as the Kakapo had known it. The story does not begin in 1995. It begins 60 million years ago, when the landmass that would become New Zealand broke away from the supercontinent Gondwana and drifted into the southern Pacific, carrying its cargo of wildlife into isolation so complete that mammals never reached it. No land predators, no rats, no stoats, no cats. For 60 million years, the islands developed an ecology unlike anywhere else on Earth, and the Kakapo developed inside that ecology into something that makes no sense if you have ever seen a bird anywhere else. It lost its flight muscles because there was nothing to fly from. It developed legs powerful enough to climb trees because the trees were where the food was, and then it would simply step off branches and glide to the ground on vestigial wings that could slow a fall but could not sustain lift. It grew large because in the absence of predators, large was fine. It grew slow because slow was fine. It lived long. Kakapo routinely survive past 90 years because when nothing hunts you, longevity is a viable strategy. It developed a boom, a resonant infrasound pulse produced from an inflated chest sac that carries 5 kilometers through forest and draws females across the darkness of the southern island nights. It built its nests on the ground because the ground was safe. Everything about the Kakapo was a perfect adaptation to a world that stopped existing the moment the first Polynesian canoe touched the New Zealand shore around 1280 AD, carrying with it the Pacific rat. The Kiore, as the Maori called it, reached the ground nests immediately. The eggs were exactly the right size. The chicks were exactly the right weight. The Kakapo had no behavioral response to a predator it had never encountered in 60 million years of evolution. It froze. It was the only defense it had ever needed against the eagles and hawks that hunted it from above. Against a rat on the ground at a nest it had just built, freezing was a sentence. Here is how the collapse actually happened, and it is not the version you will find in a short summary. The Polynesian settlement reduced the Kakapo significantly, but the species survived in the forests of the main islands, and in numbers that early European naturalists still described in the 19th century as abundant. George Edward Gray at the British Museum received so many Kakapo specimens from New Zealand in the 1840s that he described the bird as common. John Gould wrote that its flesh was considered excellent eating and that Maori hunters used trained dogs to locate them by scent in the forest undergrowth. That scent, the honey and flowers smell that makes the kakapo one of the most distinctive smelling vertebrates on Earth, is produced by a combination of compounds in the bird's preening oil that nobody fully understands. What they understand is what it does to a dog with a trained nose. The dogs found the kakapo faster than the birds could breed, but it was not the dogs that finished them. It was the cargo that came with every European ship from 1840 onward. Ship rats, Norway rats, stoats released to control the rabbit population that was itself introduced for sport hunting, feral cats descended from domestic animals left by settlers. Each introduction cascaded into the next. By 1900, kakapo had been eliminated from the North Island entirely. By 1950, the main South Island populations were functionally gone. The Wildlife Service began emergency searches in Fiordland in the 1970s and found a small population of males, only males, because the stoats had found the ground nests and taken the females and chicks faster than the males were dying on the leks. A population of males is not a population. It is an ending written in the wrong tense. Then, in 1977, on Stewart Island at the southern tip of New Zealand, a survey team found kakapo, female kakapo, breeding kakapo. The relief lasted less than a decade because the feral cats on Stewart Island were finding the nests at a rate that the birth rate could not outrun. The decision was made to catch every surviving bird and move them to predator-free offshore islands. That operation took years. It required trapping, physical transport, quarantine, and the construction of a monitoring infrastructure on islands that had no roads, no permanent buildings, and no supply lines beyond what helicopters could carry. When the last bird was transferred and the final census was taken, the number was 12, 9 females, 3 males. The 3 males were not all unrelated. The genetic situation was already compromised before the recovery program had run a single breeding season. Don Merton, who had spent 20 years of his career searching for this bird, looked at the number and did not say it was enough. He said it was what they had. Those are not the same thing. Watch what is moving inside those 12 birds and what it meant for every decision that followed. The kakapo breeding system is unlike any other parrot on Earth, and unlike most birds in any family. The males do not pair, they do not build nests, they do not feed chicks. They walk to traditional display grounds called leks, elevated ridges sometimes used by the same lineage of males for generation, and they excavate shallow bowls in the soil with their feet and they boom. The booming is not a call in the conventional sense. It is an infrasound production, a pulse generated by an inflated thoracic air sac that the male pumps like a bellows for up to 8 hours a night across a display season that can last 3 months. The sound travels through the ground. Females detect it partly through their feet. They walk to it, sometimes more than a kilometer through dark forest, uphill, alone, and they select a male and they mate, and they walk back, alone. And that is the end of the male's involvement. The female builds a ground nest. She incubates alone. She forages alone, leaving the nest unguarded for hours each night because she must eat to produce enough crop milk to feed the chick when it hatches. The window when she is away from the nest is the window the stoats use. A stoat can kill a kakapo chick in under a minute. The female returns and the nest is empty, and she does not re-nest that season. The season is over, and the season only happens in a mast year when the rimu trees produce a superabundance of fruit that triggers hormonal changes in the female that bring her into breeding condition. The rimu trees fruit on no predictable schedule. 2 years, 4 years, 7 years. Nobody controls it. Nobody can make it happen. The entire reproductive output of the last kakapo on Earth was hostage to the fruiting cycle of a tree. But here is the detail that tells the real story. When the Kakapo recovery program brought in genomic sequencing in the early 2000s and ran the full analysis on every surviving individual, they found 2 things that changed everything. The first was that the genetic diversity in the surviving population was even narrower than field observation suggested, with several of the founding 12 already sharing significant allele overlap that pointed to a pre-transfer bottleneck on Stewart Island that nobody had fully accounted for. The second was that the birds were not expressing the level of lethal allele depression that the inbreeding coefficients predicted. Something in the Kakapo genome was partially buffering the population against its own collapse. The leading hypothesis is evolutionary memory, that the Kakapo lineage is so ancient, diverging from other parrots somewhere between 60 and 80 million years ago, that it has survived previous population contractions in its deep history, and that the most catastrophically deleterious alleles were purged from the genome in those earlier near extinctions, leaving a population that is compromised but not fatally so. Not safe, not stable, but not already dead in the genetic sense that the models said it should be. That margin, that sliver of unexpected genomic resilience, was what the program decided to build on. And the tool they chose to build with was a spreadsheet. Andrew Digby, a wildlife biometrist who joined the program in the early 2000s, proposed a breeding management strategy that had no direct precedent in bird conservation. Every living kakapo would be fully sequenced. A kinship matrix would be constructed for the entire population. Before each breeding season, the matrix would be used to generate optimal pairing assignments for every adult female. Not suggestions, not guidelines, but assignments that the field team would then physically implement by tracking female movements with transmitters, positioning supplemental feeding stations to influence which lek a female approached, and in some cases, physically relocating males to leks that the target female was likely to visit. The female would still choose, in the immediate sense that she would still walk to a boom and make contact, but the population of males she encountered would be curated. The program was not eliminating natural selection. It was selecting which version of natural selection the last birds on Earth got to experience. The ethics of this were not lost on anyone involved. The alternative was watching the genetic diversity compress to zero across 4 or 5 more breeding seasons, and the line ending in a nest that simply stopped producing viable eggs. They ran the matrix. A ranger who has worked Wenuaho for more than a decade was on island during the 2019 breeding season, which became the most productive in the program's history. The Rimu mast that year was the largest recorded in a generation. The preparation had taken 18 months. Supplemental feeding stations loaded with high-calorie food had been running since early 2018 to bring female body weights above the threshold required for egg production. Nest boxes had been installed at historically active nest sites. Every box had a camera. Every camera fed to a monitoring station where staff watched in shifts through the night. She was on camera watch at 2 a.m. when the feed from nest box 7 showed movement that was not the female. The shape that came through the entrance was a stoat. The chick inside was 4 days old. She was 40 minutes by foot from that box in the dark on a track she knew. But that does not get easier at 2 a.m. when you are running. She ran. The chick was alive when she got there. She held it against her body for 2 hours in the dark until its temperature came back up and it was stable enough to leave. She returned it to the nest. It fledged 11 weeks later. It is alive now. It is in the database. Its genome has been sequenced. It has been assigned a pairing priority for the next breeding season. What happened in the dark on that island at 2 a.m. is the program repeated across 16 people and 2 islands and every breeding season since 1995. Every loss becomes a protocol. Every protocol becomes a chick that would not otherwise exist. The 2019 season produced 249 eggs and 76 chicks, numbers that would have been unimaginable when the count was 12. The total population, which had been below 30 as recently as 2012, crossed 200 for the first time. Then it crossed 210, then 213, which was the figure published after that season's final census. The recovery is real. It is also not finished, and anyone in the program will tell you it is not finished. 213 is not safe. The population viability models used by conservation geneticists identify 500 as the rough minimum for long-term genetic stability in a species with the Kakapo's life history parameters. The program has a roadmap to 500. It requires multiple additional mast years, continued predator eradication on the sanctuary islands, continued genomic pairing management, and the kind of sustained government funding that wildlife programs in every country on Earth compete for against 100 other priorities. The roadmap is not a guarantee. It is a plan built on a margin that should not have existed in the first place. No one knows when the Rimu will mast again at the scale of 2019. The trees are monitored for early flowering indicators that would give the program 18 months of preparation time, but the trigger mechanism for a mast year is not fully understood and cannot be compelled. No one knows whether a stoat incursion on either sanctuary island, the kind of biosecurity failure that has happened before on New Zealand offshore islands, despite every precaution, could set the population count back by a number that the current genetic diversity cannot absorb. No one knows whether the genomic pairing strategy will continue to hold inbreeding depression below critical thresholds as the founding diversity continues to compress across generations. The program's geneticists track a metric they call mean kinship, which measures how related the average individual in the population is to every other individual. And that number moves in only one direction, as long as the founding pool stays fixed. It moves toward more related. The chicks born in 2019 are less genetically diverse than the birds born in 2005. The birds born in the next mast season will be less diverse than the birds born in 2019. The program is buying time. The question no one has answered is what happens at the end of the time they are buying. The nest cameras are running tonight on Wenuahu and on Anchor Island in Fiordland, the two islands where the entire world population of Kakapo lives. The Rimu trees are being watched for flowering. The genomic database is being updated as the 2019 cohort reaches sexual maturity, and their sequences are added to the pairing matrix. 3 birds that were adults when Don Merton wrote 12 in his notebook in 1995 are still alive. One of them is a female. She has produced chicks in 3 separate breeding seasons across 3 decades. Her offspring have produced offspring. Her genome is in the database, flagged for the specific alleles that the program most needs, distributed across the next generation. She moves slowly now. The rangers on Wenuahu know her individually, know her nest site history, know which supplemental feeding station she prefers, and what time of night she arrives at it. She is somewhere on the island tonight in the dark, and she is still here. And because she is still here, the number is not 12 anymore. The species came back from 12 because a number of people small enough to fit in a single room refused to let the arithmetic be final. The arithmetic said the birds were already gone. The people with the cameras and the spreadsheets and the genomic database and the 40-minute run through the dark said not yet. And the number is still rising, and the Rimu trees are still being watched.